All right, slightly different problem, but not really. It's only different at the very, very end. So here we're looking at succinic acid, which is something that is produced by lichens in nature. We are given the percent composition of it, and then we're also given a new piece of information. So see how it says blah, blah, blah. This is all so far the same exact problems we've been looking at. However, now it says that it has a molar mass, like actual succinic acid, has a molar mass of 118.1 grams per mole. Okay. In previous problems, we were not given that molar mass. We were just being asked to find the empirical formula, which is the lowest whole number ratio, and that's something that you get from the percent composition. Here we're asked to find that empirical formula and asked to find the molecular formula. Okay, and remember your molecular formulas, that's the actual chemical formula for the molecule or for the compound. All right, it's always going to be some multiple of empirical formulas. So we're going to end up using this molar mass here at the very end to be able to identify the correct molecular formula. Just hang tight for the video and you will see exactly how that is done. The first step to finding a molecular formula is always going to be to find that empirical formula, so we're going to do the same thing we've been doing. All right, take the 40.68% carbon and swap colors so we still have room. So we got 5.08% hydrogen and 54.24% oxygen. Okay, go ahead and you can convert all of those into moles, not moles, grams first. All right, so we get 40.68 grams of carbon, we get 54.24 grams of oxygen, and we get 5.08 grams of hydrogen. We can convert them all to moles. So 1 mole of carbon is 12.01 grams of carbon. Okay, since I'm using green, I'm going to jump down here. So 1 mole of oxygen is 16 grams of oxygen. That'll give us moles of oxygen. And for hydrogen, we know that 1 mole of hydrogen is going to be 1.01 grams of hydrogen. This will give us moles of hydrogen. Okay, let's do the math. So I'm going to take 40.68 and divide it by 12.01. This gives us, remember to do 4 decimal places, so 3.3872 moles of carbon. For moles of hydrogen, I'm going to take 5.08 and divide it by 1.01. Oops. So we get 5.0297. Okay, so I'm going to cut it right there. That's a 0, so the 7 is going to stay the same. And then for oxygen, I'm going to take 54.24 and divide it by 16. So I get 3.39. I'm going to add 2 zeros so I stay 4 decimal places just to remind myself to always do 4 decimal places. Okay, to find their relationship to each other, we need to divide each of them by the smallest. Now here, these are basically the same number. I'm still going to choose the exact smallest. So divided by 3.3872, that's going to give us 1 mole of carbon. Okay, if I take this one and divide it by 3.3, this is going to give me 297 divided by 3.3872. 1.5, roughly, moles of oxygen. 3.3872, and I know that this is going to be basically 1 because that's basically 3.39. So 1 mole of hydrogen. Oxygen. Wow. This one's oxygen, this one's hydrogen, so sorry about that. Okay, I think I saw the O down here whenever I was doing this, so I'm very sorry about that. So far, my empirical formula would be, or my ratios of the moles of elements that I would use for my empirical formula is 1, 1.5, and 1. Well, I know that I can't deal with a half number, so I need to multiply everything by 2. So 2 carbons, 2 moles of carbon, that's going to give me 3 moles of hydrogen, this is moles, and then times 2, so 2 moles of oxygen. So my empirical formula is going to be C2H3 O2. Okay. Up to this point, this has been the same problem we've been doing for empirical formulas. Now, since the empirical formula is always the lowest whole number ratio and the molecular formula is some multiple of that formula, we can see how many times this molar mass, or how many times the molar mass of your empirical formula goes into the molar mass of your actual molecule. Basically, is this mass going to be equal to the mass of 1 mole of this empirical formula, or is it going to be equal to 2 times this empirical formula, or 3 times? So what you have to do first is find the molar mass of your empirical formula. Okay, so the molar mass is going to be, let's actually, I'm going to use a pen or maybe a finer point for you to be able to see this. So I'm going to take for carbon, hydrogen, and oxygen. Yeah, you can see that. I'm going to take the molar masses of each. So 12.01 grams per mole. I'm going to slant it so we can fit. Okay, times 2. So that's from carbon. All right, 1.01 grams per mole for hydrogen times 3 moles. Okay, and then for oxygen, 16 grams per mole. And I've got 2 moles of oxygen there. So 32 grams per mole. And if we add that up, the molar mass of my empirical formula, EF, we're going to have 32 plus 24.02 plus 3.03. So 59.05 grams per mole for my empirical formula. Okay? You know that your empirical formula times some number is going to equal your molecular formula, the molar mass of this. So times, what we'll do, times X equals your molecular formula, or XEF is equal to your molecular formula. Okay, so to find how many times to multiply our empirical formula, we can take the molar mass of our empirical formula and divide it out, and take the molar mass of our molecular formula divided by the empirical formula's molar mass to see that multiple here. So I'm going to take this 118.1 grams per mole and divide it by the molar mass of my empirical, 59.05 grams per mole, to find X. Okay, some of you guys probably can tell what that number is going to be, but let's go ahead and plug it in. So 118.1 divided by 59.05, we get 2. So my molecular formula is 2 times heavier than my empirical formula, meaning that my molecular formula, and let's go ahead and draw this out, my molecular formula then has to be twice as big as my empirical formula. So now I'm going to take C2, I'm going to basically take all my subscripts and multiply by 2. So C2 is now going to be C4H, instead of 3 it's going to be 6, oops, 6. I'll write over this in black so you can see it better. And instead of O2, it's going to be O4. So you get C4H6O4 for the molecular formula. And if you look here, it's still the same ratio, but this is not whole numbers. Okay, this formula here is succinic acid. However, to write its empirical formula, we got to just reduce it to the lowest whole number ratio. So percent comp always gets you here. Then you can use the given molar mass for your compound, and then the molar mass that you find for its empirical formula to see what multiple of your empirical formula your actual molecular formula is. Okay. We'll work some practice problems together too.